If it is a 30-degree angle, a 60-degree angle, or a 45-degree angle, you should not be using SOHCAHTOA for everything we do from here on out. If it is a 30-degree, 60-degree, or 45-degree angle, you should be using special right triangles, and I'm going to expect your answers in simplest radical form. If it says simplest radical form and you're using SOHCAHTOA, those two things won't work out. You cannot use SOHCAHTOA and leave your answers in simplest radical form. So be very careful. This is super important. All right, help me out here. Raise your hand if you got an answer for number 1. Okay, only a few of you got an answer for number 1. All right, somebody tell me what you got. They gave us the hypotenuse. What are the two legs? 1 foot and? Okay, and the square root of 3 feet. You can put a 1 in front of that, but it's not necessary. So remember with your 30, 60, 90. 30, 60, 90. The hypotenuse is 2. First thing we did is we went around the triangle and we labeled our sides. L square roots of 3, 2L. Again, if you don't have that memorized, you have to memorize it. At this point, if 2 equals 2L, you divide by 2. What was L? 1. That means across from the 30 is 1 foot. Plug your 1 in over here. Across from the 60 is 1 square root of 3 feet. Questions on number 1? Okay, let's try number 2. 2 is a 45, 45, 90 triangle. That changes. What's across from the 45s? 4 in the problem, but L in our formula. And what's across from the 90? L square root of 2. They tell us one of the legs is 4. So what's the other leg? 4 units, inches. And if L is 4, then what is the hypotenuse? 4 square roots of 2 inches. Don't forget your units. Questions on number 2? Okay, 3 was the hardest. On the last one, 30, 60, 90, we have the longer leg is 3 meters. Which leg is the longer leg? The one across from the 60, not the hypotenuse, because we don't call the hypotenuse a leg, but the hypotenuse is your longest side. So the longest leg is across from the 60. Then you plug in your formula. So this is L. Oops. Maybe. Forget it. L, 2L, and L square roots of 3. All right, what do we do then to find L? Divide by the square root of 3. So we have L square roots of 3 equals 3. Divide by the square root of 3. So L equals 3 over the square root of 3. Are we allowed to leave our answer like that? No. Multiply by the square root of 3 over the square root of 3. And you get 3 square roots of 3 over 3. Can we leave our answer like that? No, the 3's cancel. So what is L? The square root of 3. If L is the square root of 3, then that means across from the 30, our side length is? Careful, across from the 30, our side length is square root of 3 meters. And across from the 90, it is 2 square roots of 3 meters. Questions? Everybody really is good with conversions and special right triangles. Okay, we're going to go through. Do not look at your formula sheet right now. Without looking at your formula sheets, let's see how prepared you are for the formula test that you will have after spring break. So say it out loud if you know the answer. What's the area formula for a triangle? 1/2 base times height. Make sure you put A equals on your formula test. Square, what's the formula? S squared. Side squared. It is a base or a height or a length or a width, but we call it a side length, and it's S squared, and I will be picky that you put S squared. Okay, rectangle, what's the formula? Base times height. Circle, what's the formula? Pi r squared. Put your pi in front because pi is a number, and you always put your number in front of your variable. Perimeter for a square. 4S. Rectangle perimeter. Okay, and we did say you can do 2L plus 2W, and I'm fine with that, but the book's going to do 2B plus 2H. Okay, you will need your formula sheet in a minute, but don't pull it out yet. Circle, what was the circumference formula we talked about for circle? 2 pi r. We did not talk about the second circumference formula, but we did back in chapter 1. What's another option? Diameter times pi, or pi d. You'll need to add that to your notes, to your formula sheet, because it will be on your formula test. So add that. At the end of the day today, you are going to have all 15 formulas that you need to memorize. Formula test will be not the day we come back from spring break, but it will be that week we come back from spring break. So you won't have any math homework, but you may want to review your formulas maybe that Sunday night before we come back, just to kind of get your mind back into the groove of what we've been learning, okay? All right, so these 8 formulas were not new. 8 of your 17 were from chapter 1. You learned them back in August. These 5 formulas, even though it says 4, remember there were 2 for the rhombus. Those are new. And then we're going to add on our board today 2 more. So this is 8 plus 5 more is 13. And I'm going to give you 2 more formulas today, and that's the end of the formulas. There's 15 that you need to have memorized. Okay? Parallelogram, you remember, is A equals base times height. Trapezoid is A equals okay, be very careful. What do we do with the bases? Add them. What do we do with the diagonals in the kite? Multiply them. So this is A equals 1/2 D1 times D2. The rhombus is a parallelogram, so it has the same formula, A equals BH. And a rhombus has perpendicular diagonals just like the kite, so it is also A equals 1/2 D1 times D2. Okay? 2 new formulas you can add to your notes today. So the 5th and 6th new formulas that you're going to need to have memorized. The 5th one is for the equilateral triangle. Equilateral triangle. It is a shortcut formula. You can use 1/2 base times height, but it is the longer way to work the equilateral triangle. So I'm going to show you a shortcut formula today. The 6th formula that we're going to learn today is the area of a regular polygon. Remind me, what does regular mean? We did talk about concave versus convex. All regular shapes will be concave, or excuse me, convex. They cannot be concave. But what does it mean to be regular? Equilateral and equiangular. So in order for them to be equilateral and equiangular, they will have to be convex. They can't cave in because then you'll have a very obtuse angle inside your figure. So regular polygons are equilateral and equiangular. We already know 2 shapes up here on the board that are regular. What's one shape that's regular? A square. You can use this formula that you're going to learn today for the square, or you can use this formula, A equals S squared. Okay? On the formula test, I'll be looking for S squared, and I'll be looking for the new formula you're going to learn today for regular polygons. The second regular shape that we know, we haven't learned the formula yet, but what shape up here on the board is also regular? Equilateral. If it's equilateral, it's also equiangular. We're going to learn a formula for it today. You can use that formula. You can use the area formula for a triangle, or you could use the regular polygon formula. So there's going to be 3 options if it's equilateral that you could use. This one we're going to learn is going to be the easiest. Okay? Lots today. I'm going to start with the equilateral triangle, which is not in your notes, and I'm going to ask you to add this to your notes somewhere on your paper. I don't know why this book doesn't talk about it very much, but it's very helpful for a shortcut, so I'm going to show it to you. My other textbooks in the past always did teach it as a separate formula. Okay, so if you'll add this up here on the board to your formula sheet, area for an equilateral triangle formula is A equals side squared, S squared, times the square root of 3 divided by 4. Side squared, square root of 3 divided by 4. S squared, square root of 3 over 4. A equals that formula. I'm going to show you a problem. Please write this down on your notes. I'm going to show you the long way to work it and why the shortcut's much easier. So on your paper, draw an equilateral triangle with a side length of 4. Then we're going to try to use our formula for a regular triangle, any triangle. So what's my formula for area of a triangle? Base times height divided by 2. Okay? Do we know the base of the triangle? Yes, what is it? 4. Do we know the height of the triangle? No, we're going to have to find it. To find our height, remember that you draw your height in perpendicular to the base. So if my base is 4, there's my height. If this is equilateral, what will that height do to this base? Split it. So what is each piece? 2. Okay, there's going to be 2 ways you could work the problem from here to find your height. Does anybody see one way we could work the problem? Okay, so one way would be that it's going to be a 30, 60, 90 triangle because if it's equilateral, it's equiangular, meaning that each of these angles are 60. And when I draw in that height, that makes this 30 and 30. So one way would be the 30, 60, 90. Across from the 30 is L, which is 2. Across from the 60 is L square roots of 3. So if L is 2, our height is going to be 2 square roots of 3. So then we would plug that in, 2 square roots of 3, and then do the math. What's 4 times 2? 8 square roots of 3, and then we would divide that by 2. So we would get 4 square roots of 3. Do you see how we could use 30, 60, 90 there to find the area the long way? Okay. Does anybody see another way we could have found the height without using 30, 60, 90? Pythagorean theorem. We could have done 2 squared plus h squared equals 4 squared, and then solved for h. Does everybody see that? Questions? Okay, let me show you the quick shortcut using our formula from today, though. Instead of doing either one of those ways, if we did our formula, a equals s squared, square root of 3 over 4. As long as you know the side length, it's really simple. What's going to go in for s? 4, the side length. 4 squared, square root of 3 over 4. What's 4 squared? 16. 16 square root of 3 over 4. What's 16 divided by 4? And we get 4 square roots of 3. Which is exactly what we got over here, but we had to use our 30, 60, 90. Took a little bit longer. Do you see how that's much quicker? S squared, square root of 3 over 4. Okay. If you use this method, you have to memorize the formula to use that method. And if you have the formula wrong, you're going to get the whole problem wrong. Most of you know 1/2 base times height or base times height divided by 2 at this point. So worst case scenario, you're going back and working it the long way if you forget this formula. But I am going to test you after spring break, and this is going to be on your formula test. Questions on equilateral triangles? Okay, so today's lesson is really just 2 things. One, circles, which I feel like you already know. The only reason I'm going to spend some time going over circles is because they're going to make you work backwards and use your algebra skills, and so I'm just going to review a few problems like that. And then the second thing that's in the notes today is how to find the area of a regular polygon. So I want to make sure you're clear. We have a shortcut if it's a square. We can just do s squared. We have a shortcut if it's an equilateral triangle. I'm going to show you a shortcut today for a hexagon. And then I'm going to show you a formula that would work for any regular polygon. A square, a triangle, a hexagon, a pentagon, an octagon, a decagon, a dodecagon. And those are the kind of problems that are going to be the hardest that you have to do on your homework. Okay? So we'll start with the circles. You already have all the formulas for the circles. You already know the formulas for a circle. So I'm going to skip straight to the formulas and the work. Vocab is up here. We've already talked about a circle. A circle is just the set of all points in a plane that are a fixed distance from a fixed point. I do want to emphasize this real quick because we haven't talked about how to name a circle. But if this is my fixed distance and this is my fixed point, what is this point called? Center. What is this fixed distance? Radius. So the circle is all of these points. Okay? What we haven't talked about is how do you name a circle. So make sure you notice this in your notes. You use this symbol and the center. So if I want to name that circle, I would call it circle A. If I want to name this circle, I would call it circle C. You draw a little circle, you put a dot in it, and then you use the letter that's the center. That's really the only thing we need to talk about here. We all know that 2 radii is the same as 1 diameter. Okay? So I'm going to just jump straight to the formulas, skipping all of that. Here's the formulas in your notes because we've already learned those before. And let's work some problems so we can get to the harder stuff. What does this want me to find? Area. Notice it says in terms of pi. So here's super important. Listen carefully. This is a Lashley rule, not a book rule. We will not ever use 3.14 for pi. The only time that I'm going to break that rule is if it's a multiple choice question and you're trying to pick from the choices and the directions say use 3.14. Then in order to pick the correct answer, you're going to need to follow those directions. We will always use the pi button on our calculator because it is more exact. Okay? So never are you going to use 3.14. Are we all clear about that rule? Second rule, if it does not say to round, it's just like square roots. You're going to leave your answer exact, meaning in terms of pi. So pi will be in your answer. Treat pi just like you would an x. Do it just like you would anything else, just like an x, until the very end of your problem. And then if it says round, you can type it into your calculator and round it. So what are we trying to find? Area. What do we write on our paper to start with? Formula. A equals pi r squared. What is the 6 in the picture referring to? Diameter. If they mean radius, they'll shift it. They'll put the 6 like over to one side, or they'll put the 6 over to one side up here. But if it is right in the center of your picture, then they're talking about the whole diameter. Okay? So if the diameter is 6, what's the radius? 3. We do that by dividing by 2, right? So plug it in. Pi times 3 squared. Don't use your calculator. What's 3 squared? 9. Leave it in terms of pi, so pi goes at the end. 9 pi. What are the units? Inches squared because it's area. So again, treat pi just like an x. Unless you're going to type it in on your calculator and then you'll use the pi button. Any questions on those? Okay. Maybe. Now all of a sudden it didn't want to work. Awesome. Give me just a second. Okay. All right, I want you guys to try the next 2 questions on your own with your partner, and then we're going to check them. It's okay if you're not finished with both of them, but hopefully you're getting close. Let's check the first one. Again, make sure you're reading the directions, that you're understanding what they're giving you, and you're starting with your formula. So circumference is what they're talking about. So that is 2 pi r or pi d, but because they said find the radius, then that would tell me to use 2 pi r. They give me the circumference. Be very careful that you notice the pi. Every year I have students who don't see those little pi's, and they end up getting the problem wrong. So this is 65x plus 14 pi equals 2 pi r. So plug it in for your circumference. What do you think would be the next best option to do to solve? Divide by pi. You could do 2 pi all at once if you want. that's fine, but definitely divide by pi first and get rid of that pi. So that gives us 65x plus 14 equals 2r. And then at that point, we need to divide by 2, and just make sure you divide every term by 2. And so you should have ended up with 32.5x plus 7. What are the units? Meters. And that is your radius. Watch your units. This chapter, oh my goodness, so many places you could lose points for units. And even though it's just a half a point on a test, if you do that 5 times, that's 2.5 points. 10 times, that's 5 points. That's huge. So be careful. Questions? Okay, next one. They give you the circumference again, or ask you to find the circumference, sorry, and they give you the area. So start with what you're trying to find. What's the formula? 2 pi r. That means we need to know the radius. We don't know the radius. So then we're going to go to the next thing they tell us, the area. What's the area formula? Pi r squared. We're going to take and plug in our 25x squared pi, don't forget the pi, 4a. 25x squared pi equals pi r squared. Okay, be careful. One of the biggest things you're going to be using a lot in Algebra 2 as well is the square root option, but you cannot take the square root until you have what is being squared by itself. What's the only thing being squared here? R. Well, x is also, but over here is just r. So that means we need to get rid of the pi first. How do we get rid of pi? Divide by pi. So the pi's cancel. Now we have 25x squared equals r squared. There are 2 variables, but you're trying to find what for your problem? Circumference, which means you don't need x, you need r. Okay, so we're not trying to solve for x, we're trying to solve for r. So what do I do to solve for r? Square root. Be careful. When you do that, you're taking the square root of 25 and the square root of x squared. What's the square root of 25? And what's the square root of x squared? X. Okay, so the radius is 5x. Plug it in to your circumference formula. And then simplify. Does it say to round? No, so your answer is still going to be in terms of pi, and it's also going to be in terms of x. But you can simplify this. What can you do to simplify? Multiply. What can I multiply? 5 and 2. 2 times 5 is 10. Do I put x pi or pi x? Which one's a number? Pi. So it should be pi, then x, because pi is a number. X is a variable. Numbers go in front of your variables. So it's 10 pi x, not 10x pi. That would be like saying my answer is x9. That just sounds crazy after you've been doing algebra for a long time, right? You don't say x9, you say 9x. So you wouldn't say 10x pi, you would say 10 pi x. All right, units. Feet. And we're done. Questions on those 2 circle kind of problems? Okay, again, to me it was more the algebra that I wanted to go over here than it was really the geometry part. I want to remind you in the next slide that as you're working through the problems today, I already told you we are going to use our pi key, not 3.14. And I always want to remind you this, I've said this several times, do not round until the last step. Never round in the middle of your problem, okay? I'm not really going to work through this example. Let's just talk about it real quick, and then you should be able to do it easily. Read it for just a minute. Okay, what does it want you to find? The area of each stone. So instead of working all 3 of them, I'm just going to work one of them because it would be the same for all 3. But you've got a 24 centimeter diameter, and then a 36 centimeter, and then you've got a 48 centimeter. So you would do the same thing on each one of these, except your diameter is changing. So let's just work the first one and then we'll move on, just to make sure you can use your calculator correctly. So if the diameter is 24 and we want to find the area, what's our area formula? Pi r squared. So we don't know the radius. How do we find the radius if we know the diameter? Divide it by 2. So diameter is 2r, which means if I take 24, I need to divide by 2. What's the radius? 12. Plug it in. What is 12 squared? Okay, 144. So if it said leave your answer in terms of pi, or it did not say to round, you would put 144 pi as your answer. But this one says round to the nearest tenth, so grab your calculator, find your pi key, make sure you can type that in correctly. Anybody not know where the pi key is? Let me know if I need to show you, or if your neighbor can show you, that's great too. What is 144 times pi to the nearest tenth? I heard 452.4 from 2 different people. Anybody not getting that? Okay, what are my units? Centimeters squared because it's area. Any questions on circles? Okay, so that, would you agree, pretty easy? Maybe a little bit of algebra there you had to think about when you were taking the square roots of 25x squared or how to work backwards, but not too bad. It's the next part that we have to work with. It's a little bit harder, okay? So first of all, before we get into this, I want you to look at this next example. Here. So skip all the way to here. Everybody find this example. And I'm going to show you a shortcut that only works for hexagons. So make this note in your notes. Shortcut only for hexagons. And again, I'm going to remind you, we have a shortcut for squares, right? Side squared. We have a shortcut for equilateral triangles. S squared, square root of 3 over 4. Any other regular polygon we're going to have a formula for. Except I'm going to show you another shortcut that works for just hexagons. And then after the hexagon, every other shape that's regular, a regular pentagon, a regular octagon, a regular heptagon, dodecagon, decagon, you're going to have to use the long method. But I'm going to show you a shortcut. If you get a hexagon and you want to work it this way, you can. And then we're going to go back and work this problem the long way so I can show you how it really works. And then we're going to work some harder problems. Okay, so first of all, hexagon has how many sides? 6. So draw a hexagon on your paper. Remember, it's a regular hexagon. This is only for regular shapes today. Regular, equilateral, equiangular. What's the side length of the regular hexagon? 6. So that means all sides are the same and they're all 6. Okay. One word we're going to talk about that I skipped already is center of a polygon. The center of a polygon is the same as the center of a circumscribed circle. So if we were to draw a circle that touched every vertex, the center of that circle is the center of your hexagon. Does that make sense? Okay. Then what would these distances be that go to the vertices? Okay, so again, what would each of these pieces be? I'm hearing you say it, radius. Everybody agree those are radii of the circle? Okay, and what do we know about the radii of every circle? In that one circle, every radius is what? The same. So would you agree that this is a special isosceles triangle? Okay, how many isosceles triangles could we draw in this regular hexagon? 6. So I'm going to draw all 6 of them in here. Is everybody following me so far? So if I had a pentagon and it was regular, how many isosceles triangles could I draw in a pentagon? 5. If I have a dodecagon, 12. Okay? So this first thing is true for all shapes. You can divide every regular polygon into triangles, and they're going to have the same number of triangles as they do sides. Do we all agree with that? Okay? And if it's regular, all of the triangles are going to be isosceles. Are we agreeing with that? Okay, but the hexagon's special. The hexagon is not just an isosceles triangle. It is more than isosceles, and let's look at why. First of all, if I put all of these angles together and added them, what would all of these angles add to be? 360. Do you guys agree with that? Okay, and so if I take 360 and divide it by how many triangles I've drawn here, what would each of these angles be? 60, because I'm going to take 360 and divide it by 6. Okay, this right here is going to be really important in a minute, but I want to make sure you understand where we're getting that. So everybody see 360 in a circle divided by 6. Okay, so if this is 60 degrees, now I'm going to focus on just one of these little isosceles triangles. If this is 60 right here, and it's isosceles, what does that mean about these two angles? Okay, they're going to have to be congruent. And if I take 180 and subtract 60, that leaves me with 120. And since these have to be the same, if I take 120 and divide it by 2, I get 60. So this turns out to not only be isosceles, but it's also what? Equilateral, because it is equiangular. The hexagon is the only regular polygon that we're going to talk about that turns into equilateral triangles. The pentagon, the octagon, the dodecagon, the heptagon, they will not be equilateral. They will just be isosceles. So what I'm going to show you is only special to the hexagon because they're equilateral triangles. Are we good so far? Okay, how many equilateral triangles do we have in this picture? 6. So what you can do is find the area of one of your equilateral triangles using your new easy formula and then multiply that by 6. And that's the shortcut. That's the easy way to find the area for a hexagon. So the area of your hexagon will equal the area of a triangle times 6. Now in every polygon, you could find the area of one triangle and multiply it by how many there are, but they won't all be equilateral. Only the hexagon has this nice, easy little shortcut. Does that make sense? Okay, so let's work it for this problem. What's the side length again for all of my sides on my hexagon? 6. So let's plug in our formula. What's the area formula for a equilateral regular triangle? S squared, square root of 3, divided by 4. Say it, write it, memorize it. We're only multiplying it by 6 because we have 6 of them. If I were just finding the area of a triangle, I wouldn't multiply it by 6. But I'm finding 6 of them because I'm finding the hexagon. So the area of my hexagon is 6 of these triangles. What's each side length again? 6. So we're going to plug in 6 here. We have 6 squared times the square root of 3 divided by 4. And then we're going to multiply that triangle times 6 of them. And now we can do the math without our calculator because it says in simplest radical form. So we don't want to round. Treat the square root just like you would an x until the very end. Leave it at the end of your answer. So what is 6 squared? 36 divided by 4. 9. Can I go ahead and simplify all of that inside to 9 square roots of 3? And then we have that times 6. Is everybody following me there? And then if I multiply, what's 9 squared to 3 times 6? 54 square roots of 3 units. They didn't give me any, but it would be units squared. Questions on the hexagon? Okay, we're going to come back and work this again the long way after I go through some vocabulary with you. And then the long way will work for every regular polygon. It'll work for the triangle, it'll work for the square, it'll work for the hexagon, but it's what you have to use for the pentagon, the octagon, the heptagon, the decagon, so forth. Okay? So let's go back to the vocab I skipped. Right here. We already talked about the center. I'm going to draw this hexagon again up here just to kind of refer back to it. It's in your notes, I think, on the next picture below is a pentagon. I'm going to draw a hexagon up here. Here's my center. It's equidistant from the vertices because we just talked about what are these distances actually? the radius of the circle that would be around it. So these are always going to be equal, which is always making it isosceles. Here's our new word we're going to need to know today, and that's the apothem. The apothem is the distance from the center to a side. Do you draw distances diagonally? No. How do we always draw distances? Vertically perpendicular. So I'm going to go from the center to the side perpendicular. That is my apothem. Look at this little triangle here. I'm going to redraw it bigger. If this is my apothem, what is the apothem the same as in a triangle? The altitude, which is the height. So the apothem is just a fancy word for the height of a triangle inside your regular polygon. Okay? But we're going to call it apothem. So the apothem could go from the center to any side. So if you look at this next picture in your notes, notice they've drawn the apothem here. This is your apothem. It could go here. It could go here. Center to side perpendicular. Just the height of a triangle. Okay, the next thing that you're going to have to be able to do, and some of your homework is just this. It's going to say find the central angle of your polygon. You're going to need to know the central angle for this long method we're going to look at, but some of your homework is just find central angle. The central angle is the angle formed by the vertex, and it passes through two consecutive vertices of your polygon. The vertex has to be at the center. Okay, that's wordy, so let me show you what I'm talking about. So if you look at the picture in your notes here, and erase all the stuff I drew. Your central angle is what I started talking about a few minutes ago. I just didn't call it that. Your central angle goes from the center to two consecutive vertices. So it is the angle inside one of your triangles at the center. The angle that's inside one of your triangles at the center. That's your central angle. How did we find our central angle a few minutes ago? Exactly. We did 360 divided by 6 because we had a hexagon, but if this is a pentagon, to find that central angle, we're just going to do 360 divided by 5. What's 360 divided by 5? 72 degrees. Okay? So if you have any size polygon, you're just going to do 360 divided by the number of sides. That's your central angle. Any questions on vocab? Apothem, center, or central angle? Okay, we're going to go back and we're going to work the hexagon using this long method, which I'm going to show you the formula for. Okay, so ignore this for a second, but look at this with me on your paper, but ignore what they've written. I'm going to try to show you where they're coming from here. So if I'm looking at my hexagon, and again, I'm trying to get you to understand where this comes from, so maybe you'll memorize it better. We said one way to find the area was to take the area of a triangle and multiply it by 6, because we had 6 of them, right? Okay, so instead of using the shortcut formula, what is our actual formula for area of a triangle? No, not using these letters. In any triangle, what is our formula for area of a triangle? 1/2 base times height. Everybody okay with 1/2 base times height here? Okay. And if it's a hexagon, it would be times 6, right? This is going to be whatever you have. Pentagon could be 5. Octagon could be 8. Just depends on. So this is the number of sides of your triangle. Okay. We talked a few minutes ago about the height of our triangle. What did we say the height of our triangle is actually called today? What's the new word? Apothem. So is it okay with you if I change this H to an A? Okay. So I have 1/2 base times A times, in our case, 6. Are we okay with that? Okay, I'm multiplying, and the order you multiply in does not matter, right? 3 times 4 or 4 times 3, it's the same thing. So I'm going to rearrange this and put 1/2 A, and then I'm going to put 6b together. So instead of doing 1/2 b times a times 6, I'm going to put 1/2 b times 6 times, or 1/2 a times 6 times b. Is that okay? Just rearranged. What would be the base in this picture? The side length. It's the same as the base, right? And what do I have if I have 6 bases? The perimeter. Do you guys agree that 6 bases, if this is a hexagon, is just the perimeter of the hexagon? So can I change this 6b to capital P for perimeter? And that's your formula. The new shortcut formula, add it to your formula sheet for any regular polygon. Instead of finding the area of each triangle and multiplying it by how many you have, which is the hard way to do it, you can simply do 1/2 the apothem times the perimeter. And the apothem is just the height of a triangle. The perimeter is the perimeter of your regular shape, whatever that is. Okay, so let's do the hexagon again, but this time using our formula. So go back to your notes, find somewhere to work. It can be by that hexagon problem. If you're watching the video, I'm going to work it here. But we're doing that example that we just did for the hexagon that had a side length of 6, but now we're using our formula. So we're not going to do 6 equilateral triangles because that only works for the hexagon. We're going to try the longer method. So what's my formula for any regular polygon? 1/2 apothem times perimeter. Lowercase a, capital P for perimeter. All right, first part should be pretty easy to find for perimeter. How many sides do we have? 6. So my perimeter should be 6 times the length of the side, right? And what's the length of each side? 6. So 6 times 6 is 36. If you know the side length, the perimeter is going to be pretty easy. They are not always going to give you the side length, but if they do, that part will be easy. Plug it in. So now we have 1/2. We still need the apothem, but we know the perimeter is 36. Are we good so far? Okay. Now we need to figure out our apothem. Before you can find your apothem, you're going to need to know what one kind of triangle is inside your picture. So you're going to need to draw that triangle. And we already know that in every regular polygon, these triangles are going to be what kinds of triangles? Isosceles. Now for our hexagon, we know that it's actually equilateral, but we're working this the long way, so we're just going to look at it as isosceles right now. And then we need to find, the next thing we're going to need to do is find our central angle, because we need to know what kind of triangle we have. And again, I'm approaching this like I didn't know that it's a 60, 60, 60 triangle, okay? So if I didn't know if it's a heptagon or a dodecagon and I don't know what this angle is, I need to find it. How do I find that angle? 360 divided by the number of sides, in our case is 6. So we found out our central angle was 60. So this is 60, which means when we draw in our apothem, it splits that 60-degree angle into 30. And if this is a right angle from our apothem, then this is a 30, 90, 60 triangle. Okay, so if you result in a special right triangle, you should not be using SOHCAHTOA on the homework. Only if it's not a special right triangle. So I'm going to redraw this special right triangle. This is 30. This is 60. I'm looking for the apothem, which is the height. This was 6, so this was 6. So when I drew in my apothem, what does it do to that base? Splits it, so this is how much? 3, and this is 3. Be careful, biggest mistake I saw on the last test, and I usually see, is when that's 9. What's half of 9? 4.5, but several times students will put 3 and 3 because they're thinking 3 times 3 is 9, so be careful. All right, so this is 3. All right, our goal is to find A. Use what we just did in the bow work. We need the apothem. What's across from the 30? L. What's across from the 60? L square root of 3. If L is 3, then what's the apothem? 3 square roots of 3. Once you know your apothem, you're just going to take that and plug it in for your apothem in your formula. Sometimes it's going to be easier like this, where it's a special right triangle. The one we're getting ready to do is not as easy as this. Plug it in. We have 1/2, 3 square roots of 3 times the perimeter 36. Again, it did not say to round, so we're not going to type that square root into our calculator. Leave it at the end. What's half of 3? 1.5. What's 1.5 times 36? 54. So we get 54 square roots of 3. They didn't give us units, so it would just be units squared if they did. And is that the same answer we got when we did the 6 equilateral triangles? 54 square roots of 3. So if you work a problem that's not a hexagon and you choose not to do it the little shortcut way, if it's a hexagon and you do it the long way, or it's not a hexagon, like a heptagon, octagon, dodecagon, decagon, if it turns out to be a special right triangle, this is what you're doing. You need your apothem, you need your perimeter. 1/2 of that is your answer. Any questions? You don't. You could do half of 36 and get 18, and then do 18 times 3 and you still get 54.
But you can only do 1/2.
Right. Be very careful. Distributive property is only when there is a plus or a minus sign. There's not any plus or minus sign, so now we're just multiplying from left to right. But the order of multiplication doesn't matter, so you could reorder those numbers any way you want. That's fine. So you would do 3 times 36 first, and then you would divide that by 2 and leave your square root of 3 at the end. Any other questions? Okay, let's try the hardest ones. Last one. We're going to do one of the 2 that are left, so we'll just do the hardest one, which is this one. Okay, heptagon. Find the area of a regular heptagon with a side length of 2 feet. Okay, some of these pictures are going to be hard for you to draw just because you're not a math person and you haven't drawn shapes the whole time growing up, like all the last 18 years like I've been doing teaching, so it's going to be a little harder and I'm still not good at it. Find a picture in your book, or if you can't find a picture of it, remember that all we really focused on in this shape, we didn't really use the whole hexagon, did we? What did we really focus on? One of the triangles. So you can draw the entire heptagon or the entire dodecagon, which is 12 of those triangles put together, or you can focus on just one triangle out of your heptagon if you need to. Heptagon has 7 sides, so do your best to try to draw yourself a heptagon. I'm terrible at it, obviously. It's supposed to be regular. That does not look regular, but pretend that it does. So you need a 7-sided heptagon. What's the length of every side? 2 feet. Okay, we want to find the area. We do not have a shortcut for heptagons. We just use our formula. What's the area for a regular heptagon? 1/2 apothem times perimeter. So we need the apothem and we need the perimeter. Again, I'm going to warn you, sometimes they don't give you the side length. Sometimes they give you the apothem. Sometimes they give you the radius. You may have to start with your central angle and draw your triangle first to find the side length. Just depends on what they give you. This time they did give us the side length, so how do we find the perimeter? Perimeter would be 7 times the length of each side. What's the length of each side? What's 7 times 2? 14. So that part's pretty easy. Plug it in. What we don't know right now is the apothem. We need to find it. What do we need to do before we draw in the apothem? Draw what? Draw a triangle. We need to draw a triangle inside our heptagon. And maybe that's all you start with when you draw your problem is just a triangle. But you at least need a triangle. In that triangle, you need to figure out what the central angle is. How do you find the central angle? Okay, 360 divided by the number of sides, in this case, is 7. Okay, guys, are we going to round? No. So be careful. If you type that in on your calculator, it gives you something like 50, 51.4, da 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 da. You're not going to use that. If you change it back to a fraction, it's going to tell you 360 over 7. Leave it as a fraction if it's not a perfect, nice, neat decimal. Okay, so this central angle is 360 over 7. And that looks ugly, but it's just a number. All right, what do we do after we figure out our central angle? We need to split the triangle by drawing in that apothem. So we're going to draw in our height, which is our apothem. When we split the triangle, first of all, what was the base of the triangle? 2. So when it was 2 and we split it, what is each piece? 1 and 1. It also splits that angle. So now we need to take this 360 over 7 and divide it by 2, right? Which is the same as multiplying it by 1/2. So what do we end up with? 360 over 14, which is the same as 180 over 7. Again, it's going to give you a decimal. We're not going to use our rounded answer. We're going to leave it as 180 over 7. It's ugly, but it still works. It's fine. Okay, so now this little angle right here is 180 divided by 7 degrees. And it's not always going to be that ugly of a fraction. I told you this is the hardest one. Are we good so far with what we did, though? Central angle, apothem splits it into 2 pieces. Find your central angle, cut it in half. Then just focus on one of those little right triangles. So sometimes it's helpful to draw that bigger on your paper. What is this side called? The apothem. What was the length of this piece down here? 1. What was the measure of this angle? 180 over 7. So I'm just drawing this triangle a little bigger to make it easier on me. Are you guys with me? Okay, is this a special right triangle? No, so we can't use 30, 60, 90. We can't do 45, 45, 90. What did we learn to use? SOHCAHTOA. So we need to use our trig functions. You are not using those, though, if it's 30, 60, or 45. But if it is not one of the special ones, then you're using trig. So what do we call this side over here where the 1 is? Opposite. What's the A? Adjacent. So which trig function do we want? Tangent. All right. So let's set it up. Tangent of 180 over 7, we're just leaving that exact so that we're not rounding until the very end, equals what over what? Careful, opposite over adjacent is 1 over A. All right, then you can either put this over 1 and cross multiply, or we had the little trick that said when A is down below, you switch, you know. So that means these two switch. Whatever makes sense to you. If that did not make sense, then cross multiply and solve for A. And you get 1 over the tangent of 180 over 7. Does anybody need me to actually cross multiply and show how I got that? Okay, so this is A. Is this our answer? No, this is just the apothem. Once we find this answer, what are we going to do with it? Plug it in up here for apothem. So we're going to take this number on our calculator and we're going to multiply it by 1/2 and then times 14, or we could just multiply it all at once by 7. Okay, so I'm going to switch to my calculator and we're going to type this in together and make sure we can do it correctly. But everybody's with me. We're doing 1/2 this apothem, which is 1 over the tangent of 180 over 7, times 14. That's our goal. I'm not going to type it all in at once just because I think it's easier to make mistakes that way. I'm going to type it in separate. Give me just a second to pull my calculator up. Okay, here we go. So let's type in the A part first. We're going to do 1 divided by what? Tangent of 180 over 7. Oops. And then we'll close that parenthesis, hit enter, and that's our value for A. That's the A. We want to take that and either multiply it by half and then 14, or half of 14 is 7, so we could just do times 7. Rounded to the nearest tenth, it said. What is our answer to the nearest tenth? 14.5, and our units were in feet, so the answer is feet squared. Questions? Did you guys not get that? Okay. What's so funny? All right. Are we good for real? Okay, that's the hardest. Sometimes they're going to be trig problems. Sometimes they're going to be ugly fractions. Not all the time. Sometimes they're going to be easy whole number angles, but they're still SOHCAHTOA. Sometimes it's 30, 60, or 45. 1/2 apothem times perimeter. Okay, you've got all kinds of other options on the board if it's not a regular polygon. You've got the shortcut if it's a hexagon. You've got the shortcut if it's equilateral triangle, or if it's a square. But you can also use 1/2 apothem times perimeter on the square and on the equilateral triangle, because those are regular polygons. Any questions? It's not terrible. It's just not super quick and easy. All right, and what should we have checked before we ever typed in tangent? If it's in degree mode. So make sure your calculator was in degree mode, because if not, you wouldn't have got 2 point whatever for A. Okay? Any questions?